targeting thing. We're going to take a look at some more advanced types. I know it seems like we've already been advanced, having gone through with generics, but I want you to get a sense for what's possible as you learn more and more about how to design effective constraints with TypeScript. First, we're going to look at mapped types. And this involves using an interface as a way from getting to the interface's keys to the types associated with those keys. So we had a function earlier in the workshop where we were trying to contact people by phone or email, and we used overloads. We used multiple function signatures in order to ensure that email went with email and phone went with phone. This would require, as new communication methods were added, it would require us to add more signatures, right? One for each new coupling of the first and second parameter together. So we're going to use a mapped type to accomplish a similar thing. So here is our new function. It's called contact. It has a type parameter that must extend from a key of the above interface. Anyone have a hunch as to what the possible values of that could be?
Email, phone, and fax.
Email, phone, and fax. Thank you. So email, phone, and fax. And then we're taking that type and this is what makes it a map type. We're passing that key into the interface and we'll get the corresponding value associated with that key. So here, these three will all work. But if I were to try to reverse things, like use phone up here, we're going to get the same kinds of errors that we were getting with the function signatures. The first parameter and the second parameter must agree. But in my opinion, this is a little bit easier to maintain because for new communication methods, we only need to add sort of a new row to the interface. And what's more, we could use this, we could consume this type and do this mapping across many different things in our app. So if you have some concept like the different types of models that you can get from your API, and you want to refer to them by name, and then you can get that correct type back, you can have one source of truth where all of this is maintained, and then everything else that consumes the mapped type in this way, they can, like automatically get updated because they're expressed in terms of that one interface. So it's just like in the value world, this is taking, sorry, I'm scrolling here. In the JavaScript values world, this is just taking a key and passing it into an object to get its value. And the syntax is the same. So I just think of this like objects. You can, so as you said, the available keys here, like key of communication methods, email, phone, or fax, we can even get all values by taking these keys and projecting the set of the three of them through the interface to get all of the possible values. Has email or has phone number or fax. That is all three of these up here. So if you have anything where you've got A or B or C and pass it through an interface, you'll get the corresponding value of that key or value of the other key or value of the third key. Right? Pretty cool. I mean, it seems like you would hope it would work, and it does. Type queries, and I call this an advanced concept, but it's relatively simple to understand. Type of allows us to get the type of a symbol, the type of a value, I should say. Symbol is a very overloaded term in JavaScript. So here we've got a value whose type is a promise that resolves to a number, and I can get the type of what promise.resolve has, like the type of this function here, I can kind of acquire that by using the type of operator in the context of a type alias. You could do the same thing like this. Well, I do it like let. But there you go. So this is called a type query because you're kind of querying for this values type. Conditional types, this was added in TypeScript 2.8, which is pretty recent. This is a ternary operator for types. So we've got a generic here. You can only use them with generics. We're saying we want to basically grab the type of a promise or let something pass straight through if it's not a promise. So this is like, give me the eventual value that this will turn into. And if it's not a promise, that is the value itself. So we take in a type t. If t extends from promise, extract out the type that the promise resolves to. We use infer here. This is the only place you can use infer, but it lets you pluck out the type the promise resolves to. So if t extends from promise, return what it resolves to. Otherwise, just let it sail straight through. And here we can see that A is of type number. We're saying eventual type of promise number. And number comes out because we're in the truthy clause here. In B, we can see that the number array kind of sails straight through, right? Because it's following this branch down here. TypeScript comes with a couple utility types, and they've recently added a couple more that heavily depend on this conditional. Number one is partial. Partial just makes everything on a type optional. This is great if you have an options object where you have maybe a set of defaults and someone can pass you a subset of those options and you just want to do sort of an object merge, like a big splat. So take what I was given, merge it into my fallbacks, and you will have the full set of options. So partial has put a question mark next to name and email. It may have email. Pick allows us to select one or more properties off of something. So I'm saying I've created a type called has-then. It takes a type parameter, and it's going to pick off of a promise, then and catch. So let's see. So then I'm using the type. I'm extracting off of promise.resolve just then and catch. And so there they are. If I were to have just grabbed then, we would only see then. If I made this a little bit simpler, and we don't need the template here. I didn't initialize it, but we can see that only A is present. Only B should be present here. Or you could do B or A, and they should both be present. So you're picking off of an object type by property key. Extract lets us, when you have a big intersection type, it'll let you select things that are assignable to a particular type. So give me only strings. Oh, I misnamed this here. Number. Give me only numbers.